All right.
Fantastic. All right, I'm just going to start over intake. So excited to introduce our speaker for tonight, Dr. Forbes. Gregory S. Forbes retired in 2019 after being severe weather expert on the Weather Channel from 1999 to 2019, based in Atlanta, Georgia. He made behind the scenes and on-air forecasts and discussions of dangerous thunderstorm weather hazards, such as tornadoes, damaging winds, hail, floods, and lightning. He received his BS in meteorology at Penn State University. He received his MS and PhD degrees at the University of Chicago, where he studied tornadoes and severe thunderstorms under Professor T. Theodore Fujita, world famous for his invention of the F scale used to rate tornadoes and for his discovery of narrow, intense thunderstorm downdrafts called microbursts. Dr. Forbes joined the faculty in the Department of Meteorology at Penn State University in 1978, where as an assistant and then associate professor, he taught courses in weather analysis and forecasting, natural disasters, and other topics. He's a fellow of the American Meteorological Society and is a past member of the Board on Atmospheric Sciences and Climate of the National Research Council. Without further ado, it is my pleasure to now give up screen sharing and pass the proverbial microphone to Dr. Greg Forbes as he presents his talk. Despite advanced technology, we are still very disaster prone. Dr. Forbes, go ahead and take it away.
Thanks. And let's see if I can, it's an honor for me to talk to you and with you. And let's see, hopefully this will get us into the mode we need to be in. Are you seeing my PowerPoint now?
Yes.
Okay. So what I thought I would do then would be essentially reminisce over some of the advances in technology and things that have happened over the course of my meteorological career, but yet despite all of that and the advances in technology that we've seen, we're still very disaster prone. So I thought I would look a little bit at that and some of the reasons for that. Let me see if I can get this to advance. There we go. That probably is working. So a long table here. I don't want to go through in a lot of details on this, but my career spans, as you've heard, the 1968 to 72 period. I got my bachelor's in 72, PhD in 78, and the Weather Channel from 99 to 2019. So prior to that, prior to my getting a bachelor's, things were pretty primitive in terms of meteorology. The computer model initially was the equivalent barotropic starting in the 1950s. What first weather radars operationally were 1959, the first orbiting weather satellite 60, the first geostationary satellite, pretty crude resolution in 67, and the first so-called mesoscale model in 1971. So we've come a long ways since then. By 74, computerized, digitized type radars instead of just having to have an operator sit in front of a screen that lit up as the beam scanned by. Now we're beginning to get computer capabilities, processing of the data. We began to get sort of into the internet age. The first AFOS was installed at Pittsburgh National Weather Service office. And then in the 80s, some of the models that you might remember some of the names of or recognize some of the names of began to become operational. We got into the Doppler radar era for radars starting in the early 90s. And then an upgrade to dual pole in 2011 began. And finally in the 2010s, we began to get into some of the cloud resolving models. So we've come quite a long way from what had been back in, say, 1977, a computer model that was sort of operational then involved 2 layers in the atmosphere instead of 50 or 60 or more that we have now. Twice a day with the resolution of about 250 nautical miles. Now we can get some computer models that resolve clouds and have resolution of less than 2 miles. So we've come quite a long way. Some of these, for example, the HER model gives very realistic appearances of and predictions of simulated reflectivities that show things like bow echoes and hook echoes on them. And while they aren't always exactly in the correct hour or the correct county, it's surprisingly accurate, the kind of patterns that they give, with output at 15-minute time resolutions. And of course, in detection of things, we now have fantastic multi-level access to colorized, reflectivity coded, and other forms of Doppler radar that you can even use in your cell phone as you're out storm chasing, that can show us things like, instead of just blobs on the screen that we had in the 50s through 70s, now you can get debris balls and reflectivity. You can get tornado velocity signatures and the velocities from the Doppler. And now with dual pole, you can see the tumbling motion of the debris, revealing the presence of debris within a tornado in progress. So we've truly come a long way. And in many other ways as well, the kind of data that we have access to in real time is just fantastic. For example, real-time precipitation from a number of different networks. This one, the U.S. Geological Survey, that not only monitors real-time precipitation, but also stream and river discharges and gauge heights. This happens to be a gauge that's about a quarter of a mile from my home. And my backyard is right on Soap Creek, which is a very flashy creek. So today, with thunderstorms and especially a lot of heavy rain, I've been watching it get up to within about a foot or two of bankful, but it doesn't go very far out or endanger my house by any means. We have road sensors for wintertime weather monitoring in many road locations, and just all sorts of data that I would never have imagined back when I was starting my career. And in terms of dissemination of the data, instead of teletypes that clickety-clack the warnings out that the disc jockeys tore off and then read over the radio if you happen to be listening to it to get your tornado warnings. Now we have, of course, no weather radio, but we've come a long way from that. Through many different kind of platforms, you can get individual forecasts, individual warnings on smartphones, etc. But yet we still hear this phrase, "it hit without warning," which suggests still that there's links that are broken along the way. Many times it's individuals that are just not making themselves storm ready. But most of the time, there are forecasts out there, there are watches, there are warnings. Most of us in the audience tonight are meteorologists, and we're doing our jobs and better than we ever had. But the individuals still need to up their game a little bit in most cases. And once in a while, of course, meteorologically, we have a failure as well. But we've seen lots of examples of what can happen. We sort of try to take history, and we kind of know how bad things can get in general. We recognize the conditions, and we're usually able to predict them, but sort of some of the gaps come in as people are not all situationally aware. They have jobs or other things to distract them. So I always was trying on the Weather Channel to tell people as many days in advance, which is partly why we came up with Torcon, so we could sort of try to get people's attention that a few days down the line might be one of those days that had a higher than normal risk of tornadoes, of severe weather, so that when people happen to tune into the Weather Channel, they would, or onto weather.com at that point, that they would get some heads up. You need to, on Thursday or whatever day, you need to be paying special attention to the weather. And then communities need to be better prepared in many cases than they are today for extreme weather. But it hasn't been just meteorology that has changed during the course of my lifetime. It's also been changes of society as well. In particular, a big aspect of things is that the population has increased so dramatically over the past 50 years, in addition to urbanization. The population, though, look at that, 1970 was a little over 200 million. 2020, we're about 330 million people. So we've had a population increase in the United States of more than 50%. And I was kind of surprised that even in 1973, how urbanized it was, 73%, that's up 86% now. So we were concentrated in these bullseyes just there for tornadoes or other storm systems to hit. And when they do, they affect an awful lot of people. And it gets to the point where, with people trying to keep taxes low, the infrastructure may not be totally adequate for handling the extreme storms. And there's no shortage of examples of those. Me being down in the Atlanta metro area, I can certainly give a couple of what were not dramatic storms. One in 2011, a 4 to 6 inch snowstorm, another a 2.6 inch snowstorm that basically caused gridlock for pretty much the entire Atlanta metro area. One that we've nicknamed the Snowmageddon, put down a wet snow on Sunday. Now, even though it's Sunday, the limited numbers of interstates were still full of traffic, and in particular, a lot of semis that on the icy roads packed down the initial snow cover and got very slippery. And literally only 8 snow plows for the entire Atlanta metro area, or something like 6 million people. Once the traffic and those interstates got blocked, people could go nowhere. And I don't know if you've been to Atlanta or not, you may think that it's flat down in the South, but the terrain is not that different from State College. You can't go more than about 2 or 3 blocks without having to go up and down some hilly area, not unlike State College. And so if the roads and streets get icy and there's no way to clear them, things get log jammed. And another one nicknamed a snow jam hit in the morning with people at work, people trying to get home then once the schools were let out early. What should have been 30-minute drives took literally 11 hours in some cases, and cars being abandoned. They had to tow them off of the roads, the interstates, before they could really reopen the interstates. So, and we've had another example of that down in Texas, Houston, and other locations all across the state and even adjacent states. Back in February, the prolonged ice and snow and cold period led to power blackouts, which then snowballed into a water problem because of the lack of power, and turned into a real catastrophe for a very large portion of Texas and some parts of adjacent areas. So partly because of our urbanization and the huge increases in population, we're just not prepared to deal with disasters as well as we need to be. Now, I don't want you to take the viewpoint, as some people sometimes do, that well, those are threats for other places. They don't hit here. Many of you are in the central Pennsylvania area, and they indeed do hit close to home once in a while. May 31st, 1985, that radar picture there from a pre-Doppler area, the WSR-74C, operated by the Department of Meteorology. I was running the radar that day, took picture of what arguably would be a world-class hook echo with even a debris ball sitting right there inside the muscle, if you will, of the arm of that hook echo wrapping around, as the tornado went right across 65 miles across the hills and valleys of central Pennsylvania, right through the Moshannon and Sproul State Forests, part of a 41 tornado outbreak, including the only F5 tornado to hit Pennsylvania on record. So even F5 tornadoes can hit Pennsylvania, and even F4 tornadoes can hit or just north of I-80, not very far from the State College area. And my own Penn State commencement in 1972 was basically wiped out due to flooding from Hurricane Agnes. I had my ticket. The plan was for the commencement to be outdoors in Beaver Stadium, but they had a fallback position that several of the colleges would have theirs on June 24th in Rec Hall. But the problem was you couldn't get there. All the roads got washed out. I tried. I got as far as going from Western Pennsylvania, where, as a graduating senior, you basically had the week off before that while they collected all the grades and so on. So I was home in Latrobe and tried to get there. I got about as far as the first foothills in Blairsville before the road was washed out. And I thought I would try. They were broadcasting all on television that not to try to come, that there was no way to get there, but I had to see for myself. And of course, the reason for that was pretty much anywhere that had hills, from the foothills of Western Pennsylvania all the way to the Northeast, and all except Southeast Pennsylvania, had 6 inches or more across the entire state, basically, with some places getting 18 inches of rain, with, of course, runoff into these stream channels and into the river channels, wound up with massive flooding. In the lower right portion here, all of these, each one of these white dots in a diagram from the Mid-Atlantic River Forecast Center shows places that to this day, the Agnes flooding still is at the record level, and that extended down into a little bit of Maryland and Virginia as well, and up into South Central New York. So it doesn't happen all that often, but it certainly can happen. I couldn't resist putting a picture in of the Governor Milton Shapp at the time taking a boat to the governor's mansion. You can see probably, what, 4 feet of water up to the partway up through the garage doors. So even the governor couldn't drive to his own home. And of course, going back to that urbanization theme, with urbanization comes a whole slew of problems in the flooding standpoint, with more impervious surfaces. Asphalt and concrete becomes more runoff, which helps lead to higher stream flow, which then expands the floodplain. And another interesting way to think of things is that, well, if you're buying a new home these days, if you're in the floodplain, you have to have flood insurance to, well, hopefully offset for the loss if you get flooded. But if you're in a home that you've already paid off the mortgage before the floodplain expanded, you may be now in a home that doesn't have flood insurance, but is in the floodplain, and you now have a real uninsured problem. And we see too much of that. And of course, there is more flooding these days. And in terms of the denser building concentration, there's more debris to be tossed about, which aggravates in flying debris, in addition to the winds of tornadoes and damaging windstorms, as well as the urban sprawl makes the urban areas bigger targets for these smaller convective storms. So some part of the metro area gets hit more often. It's not just farmland that once was a bigger portion of the countryside. And it doesn't just have to be some part of Pennsylvania either. I took a couple of pictures here from June 17th, 1996. You're aware of the hilly terrain and some of the this happens to be Calder Alley in between Beaver and College Avenues. And if you put in 90 minutes, if you put 5 inches of rain from a stalled thunderstorm or a series of training thunderstorms right over there, you get a lot of water that builds up. Kayaking right down the Calder Alley area there, right onto Atherton Street. So it can happen just about anywhere if Mother Nature decides to do its or her worst, if I use a feminine with that. And of course, there's been no shortage of Pennsylvania floods, some of the worst of Johnstown in 1889 with 2,200 people killed, a lot of flooding rain, as well as a dam breaks. And then Johnstown hit in 1936. And even though they said after 36 they were building a flood-free city with a flood control system, still in 1977, with training thunderstorm rainfalls in catastrophic amounts, still once again a deadly flood and widespread Pennsylvania flooding in 1996. We're better off now in terms of a lot of these interstate highways have leveled off, so they don't go right down into the river channels. So maybe now with I-99, maybe I could have gotten to my commencement that got flooded out by Agnes, but still most of the city roads and local roads and so on are just the same as they were then, and are still as much and even more now due to excess runoff, vulnerable to flooding than they were back when I started my meteorological career. Now here I've taken some excerpts from a publication published in geoengineer.org, and I've taken actually the title here of their article. Over 1,680 dams in the United States are considered to be high hazards. Infrastructure is aging. President Biden actually talked about that some today. I won't get into that, but literally from this article, high risk means there's a potential threat of casualties, namely deaths, in case of a failure of one of these dams, and the lower levels of hazard would be significant, still might have economic impacts. And then they go on in the text to say that most of these dams are constructed over 50 years ago. They're obsolete. They can't address current weather conditions with an increasing amounts of extreme rainfall and floods related to climate change. They protect more citizens because of urbanization, and there are thousands, probably it's a lot more than thousands, that are downstream and of these deficient dams. And they estimate that it would cost $70 billion to repair them, many of which are privately owned and owners unwilling to or unable to pay for the upgrades. And that makes me think, does that sound a little bit like the May 1889 Johnstown flood? An aging dam had been built by the railroad, taken over by a group of private citizens for a recreational club, a sporting club, and left to deteriorate until it finally got overloaded and broke, leading to a flood and then somewhat of a fire in some of the debris there, with over 2,200 people perishing. And more recently, Katrina, another one of these systems, a dam or a levee system known to be at risk, but not having been upgraded. But even that day, it seemed like the worst of the storm surge and winds from Katrina had passed just to the east, people beginning to take a sigh of relief that maybe New Orleans had been spared, until some of the initial reports began to come in of a single levee break or a couple or three levee breaks. And of course, with New Orleans being in a bowl, that led to basically the entire bowl's region being filled in, as they are unable to, in time, repair those levees. So we have big problems in many places. Now, some things have improved during the course of my career. When we actually put regulations in place, amazingly, they work. The Clean Air Acts of 1963 and 70 have dramatically reduced our air pollution within the United States. Regulations on toxic gases. Left column will be 1970, the right column 2019. Carbon monoxide down by a factor of 3. Nitrogen oxide down by a factor of 3. Sulfur dioxides down by a factor of about 15, and the volatile compounds down by about a factor of 2. So if you regulate them, there are prices to be paid for that, but plenty of examples that it does work. Now, unregulated, on the other hand, global temperature and carbon dioxide have been accelerating. The carbon dioxide levels here in the red and yellow curves, the past 50 years, so that roughly, we start following the yellow curve, goes from about 310 or 320 up to close to 380 parts per million, and very highly correlated with the year-to-year temperature cycles here that have gone up about, well, 0.8 of a degree Fahrenheit or something like that during the course of my meteorological career. So we have not adequately regulated that, and maybe putting ourselves in jeopardy as a consequence. Now, in terms of tornadoes and severe thunderstorms, the jury is still a little bit out in terms of how global warming might be contributing to future changes of all that. My own sort of dumb guy theory or idea of things was that while I was working at the Weather Channel, I started taking note of some of these odd occurrences. Cool season, should have been talking about winter storms, winter snowstorms. Instead, I'm having to be on air as much as the winter weather expert covering tornado outbreaks. And so I started to make a list of all of these high latitude and cool season events. One of them is Pennsylvania, December 2006, the first tornadoes on record in Pennsylvania during the month of December. Of course, it was December 1st, but I won't go through all of these, but December 2015, the first time in records that December was the month with the most tornado deaths in the United States. And the first EF4 in Illinois in November, et cetera, et cetera, et cetera. So many of these make me go, that global warming, is it able to just get these warmer air masses from the low latitudes to go up into the higher latitudes, or to give us periodical winter season just warm enough to get past the temperature threshold, just warm enough that we get these big, some kind of either unknown or extremely rare event. I don't know, that the jury's still out on all of that, but for terms of heavy rain events, drought events, hurricane events, it seems like the meteorological community thinks that there's a pretty high confidence there that global warming is increasing those. Going back to the population growth, there's another complicating factor that is giving us some disaster problems. A lot of that growth has been in coastal areas, which makes them vulnerable to storm surge, climate change related sea level rises. We also have that we have more people, a lot more buildings, but in most places, with the exception of like Miami, where Andrew forced them to make some changes, most places haven't changed building codes since they were first put in place. And so they are, in most cases, 70 to 100 miles per hour is the strongest that you have to build your roof to withstand. And that's way below all but the weakest of tornadoes. So we aren't adequately building structures to resist tornadoes or even microbursts. We've had growth that is encroached into forested areas, making civilization more vulnerable to wildfires. Growth has encroached into steep terrain, making them more vulnerable to debris flows. So there's a lot of ramifications of population growth. And I was mentioning to some of you ahead of time that that are in the fire prevention aspects of the National Weather Service. Forest fires are not unknown in Pennsylvania either. Here's a picture from Boalsburg Fire Company in 2018. And there was a big one, Sproul Forest Fire in 1990, that was the worst fire in 50 years. And I remember that one from still being at Penn State at the time. So it's not just places like Gatlinburg, Tennessee, where the growth encroached close to the forest, or the weather conditions got so bad that the forest fire jumped down into the community. It can happen in a lot of places, and it doesn't have to be just out west either. In that Gatlinburg case, 16 people were killed, almost 2,500 structures damaged or destroyed. The aerial photos looked like F5 tornadoes have hit, with nothing left but the foundation or a few of the brick walls. Everything that was wood has burnt pretty much to the ground. And just like we hear, it struck without warning, some things that I wasn't too happy to hear. A little bit too much of a Mr. Magoo, if you ever seen that old myopic guy in the cartoon from back when I was a kid. The national park superintendent there from around Gatlinburg, our fire manager has never seen fires spot that far. It was unheard of around here. Well, yes, but it's certainly not unheard of when you consider that they had flames jumping from ridge top to ridge top. That's what it's talking about, spotting of the fires, burning debris embers, dropping a couple of miles away from where the fire had been. It didn't just advance as at a front. New fires formed because of being having wind-blown debris. So there was an existing wildfire, extreme drought conditions, everything was ready to burn, and wind gusts forecasted to be 60 miles per hour. That doesn't sound like a good combination. Maybe it's unheard of, but they've heard about these kind of conditions elsewhere, and you would have thought the lessons would have been learned and a more warning given to the people of Gatlinburg than was done. Santa Ana driven wildfires in California every year. Firefighters killed in Arizona from outflow driven wildfire, etc. Not very long prior to that, you would have thought would have caught the people's attention. The things you can do for wildfires and other disasters, fire resistant shingles exist. They can help make your home more fire resistant. Improved building codes could make it more fire and wind and tornado resistant. There's hail resistant shingles. Actually, not that different from, you could be hail resistant and fire resistant at the same time. And while we can't economically make homes safe to protect against 200-mile-per-hour winds, you can certainly build safe rooms or shelters that can keep you as a person safe in even the EF5 type tornadoes. And it's certainly, you can't use that, well, we never had it here before, because these kind of extreme events are rare. They're extremely rare in any particular location. Even if you live in central Oklahoma, your chance of being hit at your house but in a tornado in a single year is about 1 in 2,000. And if you get right down to it, only about 1% of the total land area of the United States gets hit by a tornado in about a 100-year period. But when you look at it the other way, there's 140 or so EF2 tornadoes somewhere in the United States every year, certainly capable of destroying a house. And if you happen to be the unlucky one, you need to be prepared. People get flooded every year in the United States. I was talking about the homes have been built, the floodplain has gotten bigger, and now people are getting flooded outside what had been the 100-year floodplain. They're caught uninsured. And lightning. The lightning death rate, fortunately, has gone down. The preparedness information has gotten out to people to lightning safety is better, but there's still people that are struck. We're not having as many deaths, fortunately, as there once were. And in terms of disasters, there's many states, including Pennsylvania, that average more than $1 billion disaster a year.
Hi,
Pennsylvania's had 56 in the past 50 years, Texas with 84. So disasters in the big picture of things are not uncommon. And you just have to hope and be prepared in case they're hitting your location. We've had 2 tornado outbreaks during my career that were so bad that we called them super outbreaks. One while I was a graduate student with Fujita in 1974, and one that I covered on air at the Weather Channel in 2011. I'm not going into any kind of detail. There, by the way, is what the radar looked like in 1974, one of those WSR 57 radars. It showed you very nicely the shape of the radar, but you on no very well-defined hook echoes. This one, by the way, is the debris ball from the Xenia tornado just forming. The tornado outbreak, 148 tornadoes in families from that. I was part of, as you're probably aware, was part of the surveying with the Fujita team to map those all out. 6 were rated F5 and 30 F4 and F5. That was the benchmark for how bad tornado outbreaks could be for, about 40 years until along came 2011. And this is only a fraction of the tornadoes from that case. 4 were rated EF5, but all told, that one had 304 tornadoes over 3 days, about 200 in a 24-hour period, and didn't have quite as many violent tornadoes, but had a little bit more path length, had a few more wider tornadoes, and hit more states. So, and the Gulf states are certainly in Tornado Alley. Dixie Alley, just the southern extension of the tornado alley, the chaser alley out there in the central part of the U.S. Tuscaloosa, Alabama, notorious for being one of the bad fortune locations with a debris ball. And these days, with our Doppler radar and computer technology, you can even do four-dimensional mappings of the tornado funnel itself. And that outbreak so bad, the tornadoes, some of them so bad that it literally ripped sod out of the ground. So things can and occasionally do get very bad. One thing that struck me, of course, tornado numbers are generally increasing because of our awareness of them and the reporting of them, but 14 of the top 20 largest outbreaks of tornadoes occurred in the 20-year period, basically while I worked at the Weather Channel. So that certainly the tornadoes are not decreasing in number. Whether they're increasing or not remains to be seen. There's too many variables to consider, and we are bigger targets for them. But certainly one thing is that when they hit a big city and they're violent, they can cause just as much death now as they did back in the early days of, or prior to Doppler, prior to any kind of radar. 1953 was the last time we had a deadlier tornado outbreak than Joplin, Missouri, where an F4, F5 tornado went right through the heart of the city. Would probably have been just as bad if Greensburg, Kansas in 2007 had been a bigger city. Donut-shaped debris ball basically flattened the entirety of Greensburg, Kansas. But there are some other bizarre things that happen as well. Again, the extremes do occur. They don't occur very often, but the remnants of Hurricane Ike staying strong with an extremely large Isala-Bark wind of intense low pressure rise because it was moving so fast behind that very large, and so it got extremely windy with the remnants of the low pressure of Ike. Even though it was almost thunderstorm free, there were essentially tornado-like winds all the way up into Pennsylvania and even New York State, all the way from its landfall position down there in extreme eastern parts of Texas. And places you don't expect tornadoes can get hit. Salt Lake City, downtown, August 1999, and a mesoscale convective vortex, pretty much unexpected, unwatched as I recall. These kind of situations even still can occur. 2016, about 30 tornadoes on a day where they were started out to be, well, it's just probably just a fluke tornado, and it kept going and going and going and going, a couple of which were rated EF3. So still, things can get extremely bad. We are perhaps more vulnerable than we ever have been, despite our forecasting abilities and our detection abilities and our ability to tell the public that they're in danger, having gone up exponentially since back when I was a student. I hope that's inspired you to keep working hard at your profession, and hope that's been of interest to you, and stay safe.
Thank you so much, Dr. Forbes. That was awesome, super informative, and really fun. If you guys want to, you can, I guess people these days do like the clapping little reaction in Zoom. We can do that. Or we can clap out loud. That's fun. Thank you much. We've got some time for questions if you guys would like. So if you guys want to go ahead and raise your hand, or I guess if we can do this in some sort of organized fashion, sort of shout it out, and we'll do some Q&A for just a little while.
Dr. Forbes, I got a kick out of one of your slides there. I think it was the Tuscaloosa tornado. I know it's a typo, but you said you were in the air at the time.
Oh,
it makes for an interesting picture. Just
so. Hi, John. That was Joplin, And I
Oh,
was,
okay.
and I literally was in the air instead of on the air. We
Oh, I'm
had been
thinking
on,
you were on the air. Okay, I thought it was a typo.
yeah, I actually was in the air at that point. We had been at storm chasing, storm tracking, as we called it. And had
Yeah.
been, we were in Kansas tracking tornadoes. We had a night vision camera the night before. And I was scheduled to go back to the Weather Channel on that next Monday morning, or to be at the Weather Channel the next day, Monday morning, because we were taping to do a special on the Superoutbreak 2011. And so I had to catch a flight. And so I was literally flying in the air. I probably saw the thunderstorm that hit Joplin. I was actually flying back to Atlanta, landed, turned the cell phone back on out of airplane mode, and they're in a frenzy to get me back. Joplin's been hit, get back to the studio. So I had to quick spin up and find out what had happened and then explain what had happened and look at the damage. Poor Mike Bettis was pretty much the first on-camera meteorologist to get there, and I'm glad I wasn't there with people injured and bodies lying all over the place. A nightmare scenario there for people that got to the area in Joplin.
Well, thanks for the presentation. I know over the years we learned a lot from you there. You know, growing up in the State College area, not growing up, but you know, the office growing up, and we learned a lot. It was really great working with you.
Yeah, I certainly enjoyed being co-located there with the National Weather Service. That was a great time for me too.
Thank you.
See Mike Colbert.
Yeah, hey, thanks for being with us tonight, and thanks for a great talk. My question is, I've always wondered about the Torcon index. What was your motivation for developing that? How did you develop it? And then do you think that people interpreted that better than, say, for example, the SPC outlooks?
Yeah, I'll go through the entirety of that process, and your questions sort of lead right into. In 2009, the Weather Channel had decided that it was going to participate in Vortex 2, the storm chasing measurement project out in the central US. And we were going to embed with the some of the storm chasing, the Doppler radar. Mike Bettis went out in the field, and in our discussions, we wanted to come up with something that we could do in the studio. I was going to be in the studio, he was going to be out in the field. And initially our thoughts were, can we come up with some kind of an index or probability of Mike Bettis seeing a tornado today? And so that's how it started, and it evolved. The seeing the tornado involved where it was going to be, because some places it's flat countryside, there'll be no obstructions by buildings or trees. If you got into eastern Oklahoma, there's a lot of trees there and some rolling terrain in the hills, you may not see it. So we decided, well, let's not go to, will Mike see a tornado? Let's just go with, what are the chances that there will be a tornado? And certainly already there was the Storm Prediction Center's probabilities, but they were using a small enough area, a 25-mile nautical mile area, that it made for some pretty small numbers. Most of the time it was a 5% chance or less, even if, that was sort of their, what would be go from a marginal to a higher type threat day would be sort of around the 5%. You went to their 10% and it was higher. So those numbers, to me, given that the public was used to thinking of sort of a threshold for a probability of precipitation, if it's 40%, it's probably going to rain. If it's 20%, it's not going to. That 30% being kind of the, less than that, we're not going to worry about it. I thought that things were not properly calibrated to get the public's attention. So the first thing I did was, well, let's go to a 50 nautical mile radius, which covers 4 times the area. So you would have numbers 4 times bigger if you were just literally using SBC and transforming it, you would be 4 times higher. So their 5% to 10% goes from 20 to 40%, and that gets you up then into the more likely numbers. So that was the first needed step, and then beyond that, all of it was my judgment, looking at the Storm Prediction Center, but also looking at all the same factors that they had, and we converted it though from a probability instead of a percentage, because it still seems like there's some public resistance to that. On the other hand, the public, anything from the Olympics to game shows where they're, doing a rating on a scale of 0 to 10, the public is very comfortable with that. And so we decided to go with a 0 to 10 rating, because people are accepting that. Yeah, okay, if it's 0 to 10, and sort of the 3 seemed to become about what the threshold was. Public not worried very much versus where you needed to worry about it. And it, with a few exceptions, there were a couple of critics out there, but for the most part, the public seemed to accept it and clamor for it. There still is a clamoring for it. Now that I've retired, it's not, unless you watch I would post it on Facebook page every day, and once I retired, that stopped, and people are, still occasionally asking for it.
Yeah, thanks so much for that backstory. Really
So
interesting.
that's the full story.
Yeah, thanks.
Up next, we'll have Nicole.
Hello. I
Hi.
just also want to say thank you for your time for this presentation. It was very lovely. I do have a question as somebody who is in school currently to be a meteorologist, and I would love to do forecasting. Has there ever been a weather event where it has really gotten to you with the amount of damage and casualties it has caused? And how have you been able to cope with that?
Yeah, there's been a couple of times during my career there on broadcasting on the Weather Channel that really shook me up. The first was Greensburg, Kansas. I actually had a little snippet on the slide. I didn't focus on that, but I was on the air with Paul Goodloe at the time, and that horrible donut of debris that showed up on the radar, and seeing that just made my heart sink, because the tornado had been heading just as if it was going to miss the town, and if it did so, it would hardly hit anyone. It made a bit of a left turn and then went and circled right over the town of Greensburg. And so just within the last couple of radar scans, the outlook got worse and worse, and then finally you saw that donut of debris. And so when I saw that, my heart sunk, because I knew Greensburg had been hit. And so it was very difficult for me to keep it together when Paul asked about what would you say to the people of Greensburg. And I think my answer was that I just avoided saying that not much I can say to them. I said, well, I think if you're downstream, because these tornadoes often cycle, there's probably going to be another tornado downstream. So if you're north and east of Greensburg, you need to be seeking shelter, because this is, could be another tornado touchdown. The other was trying to cover all of those tornadoes during Super Outbreak 2011. There were literally 20 tornado warnings or more at a time, and covering, parts of several states. And it was just virtually impossible to, literally you couldn't read the warnings and still have, fast enough to cover everyone. So I was sort of just in a frenzy of trying to quick look at the radar and see which had the worst radar signatures, and or which were coming toward the most populated areas, and hit in the time period, hit the sort of the 5 radar spots, or the 5 locations that needed most to be covered by warnings. And so that was frustrating because you knew there were other places out there that you couldn't even have time to get to. They were moving, 50 miles per hour also. So there were places that were going to be hit before you had a chance to get to them. And then information came in from North Georgia that some of the home of some of the relatives of one of the good friends that worked there behind the scenes at the Weather Channel had been hit. And that really shook me up because, then it's no longer just doing your job. You're starting to think of, gosh, one of my friends is now part of his family is homeless. So that really, shook me up some. But as a meteorologist, you have a job to do. You can't get too emotional. And that's sort of how I got through all of those tornadoes and tornado warnings that I had to go through in 20 years there.
Thank you.
Up next, Bill Gartner.
Hi, Greg. Thanks for being here. Great talk.
Thanks,
Hey,
Bill.
I just wanted to know, being a native Pennsylvanian and then spending the early part of your professional career here in Pennsylvania, what lured you to retire down south versus coming back to PA?
Well, I bought a home down here, and so and I like it. I like it down here. There are so many. There's so much to do in the Atlanta metro area, and in particular, I like to hike, and there's so many of the trails that are national park trails off of or related to the Chattahoochee River that if I wanted to, I could hike a different trail every day, and
Yeah.
maybe would take me 2 weeks before I would be hiking the same one again. So
Cool.
I like that.
Sure.
Part of my
Less
hobby
snow,
for a
too.
while was collecting things. I go out to thrift stores and estate sales and was collecting autographed books that were signed by the author. Then I
Oh, okay.
started getting duplicates and selling them on Amazon.com until my basement is so full of books that I had to stop. Fortunately,
Yeah.
the coronavirus gave me a good excuse to stop going out and
Right.
buying anymore. But so
Right.
for a while when I retired, it was so many opportunities for, as we call, picking, going out and finding
Yep.
these little gems around that
Yeah.
made it doubly fun to stay in the Atlanta metro area.
Awesome. Awesome. That's fantastic. Thank you.
Next, I'm going to go to a question that came in the chat from Glenn and Alex Rolfe. Are you seeing more tornadoes along the East Coast during tropical storms and hurricanes lately?
Yeah, there was a couple of those years, maybe 2005 and 6 or something like that. I forget the exact years now, that just had record numbers of tornadoes that kept me extremely busy during the hurricane season. I'm not sure that since then, it seemed like maybe the number of hurricane-related tornadoes backed off a little bit, but the number of landfalls is so erratic, and that I don't know that I can really talk about a trend. And just like counting tornadoes in general, compared to when I was a student, and even up through the 80s, unless Fujita or I or a handful of others went out and did damage surveys, for the most part, you didn't know about the tornado unless it really hit some, structure. So, but now there's so many damage surveys that are being done since the modernization of the National Weather Service that most of the tornadoes, I think, are getting into the archives, whereas they probably were not decades ago. So a lot of the increases in the counts of tornadoes are a result of that. The number of EF2 or F2 and EF2 and higher tornadoes has been relatively steady. It's been those zeros and ones that we're accounting for better now than we did in the past. And most of the time, that's what tropical tornadoes are rated.
Up next, we'll toss it to Amber.
Hi, Dr. Forbes. Thank you so much
Hi.
for being here and sharing your insight. It's been great. So my question is related to the information you were talking about with, now that we have this evolution of technology, but we're still hearing people say occasionally we don't see these type of events coming and these don't usually happen in our areas. So I'm curious to see over the course of your career, basically, how have you seen public risk perception for weather change?
There's been some dramatic changes back when I was starting my career in meteorology. People had no expectation of getting even a useful forecast for that day. Now they're expecting to get pretty much a perfect forecast for the whole week. So the expectations have changed, and now I think in terms of the warning standpoint, people are getting used to being told very specific locations of where the tornadoes are going to hit, the locations and even sometimes street names that are out in the additional information in the warnings is very useful. So so in terms of tornadoes, the information is there. A big problem though is, what do you do about it? If the tornado is bad enough, there's no place in your home, there's certainly no place in your mobile home to be safe. And I wonder, in the course of your career, are you going to have to deal with the warnings when we start warning on forecasts, that they're not just talking about where the storm is now and a short projection of where it's going to be, but we start issuing warnings based on these cloud resolving radars and the cloud resolving numerical models, and they're giving our forecasts of where there might be a tornado. Are we going to make things worse by people getting into their vehicles? We've seen some of that in like the El Reno and the Moore tornadoes back in 2013, people getting into the vehicles and then they're out on the roads. And the cars, of course, are extremely vulnerable to the tornado. So are we going to see more of a threat from that we're giving too much advance information and people are trying to flee? And all it needs is for one of those 30-degree tornado turns that we often get as they're getting toward their weakening stages or about to go into their weakening stages, and suddenly you're on the wrong road. The other thing that makes me nervous is a lot of TV meteorologists think that their radar is perfectly locating where the tornado is, and it's been sort of a pet peeve of mine. If the tornado is 30 degrees away from the vertical, or occasionally it gets 45 degrees away from the vertical, and the radar is 50 miles away, there can be quite a separation between where the tornado is at your radar scan versus where it is actually on the ground. And it's not out of the ordinary that's a half mile or even a mile off. And so if you're talking street level mapping without any ground truthing of somebody citing it at being at 45th and 19th Avenue or something like that, and you're telling people a street level mapping based on the radar, you might not be telling them the right information. So I hope the caution stays out there in the broadcast community to back those street level trackings up with some kind of a ground truth that it's actually where you say it is. I sort of tried to stay away from mentioning street intersections unless I absolutely knew, we had damage or a sighting report coming in. We had a traffic copter that was following it or something like that, so we could say where it was.
Yeah, no, that makes sense. Thank you so much. That's great insight.
Next, we'll toss it to Agnes.
Hey there, Dr. Forbes. I want to say first, thank you for giving such an informal presentation.
My pleasure.
I watched you growing up as a kid, so it was really your broadcast that kind of got me into severe weather and got me into broadcast meteorology. I remember watching you since like 2005. So thank you for all your dedication to the Weather Channel. My question, so I'm from Western Pennsylvania myself. Actually, my girlfriend's from Murraysville, very close to Latrobe there in Westmoreland County.
I know Murraysville very well.
Yeah. So we've noticed, or I've noticed in recent years, there seems to be a bit of an increase in concentration of tornadoes right within Westmoreland County. And I guess, do you have any sort of theory on that? I mean, I know that there are a lot of factors at play, including population, how much data we have. But do you think that sort of upslope in the Laurel Highlands has led to that increase, or is there some sort of moisture pooling or pooling of higher cape instability? Any sort of observations that you've made in your career?
I actually, it's interesting, and I'm from Westmoreland County originally, and it's interesting. I went through and on a county by county basis in about a 20-year period. The period basically since we got into the better tornado damage surveying after the modernization of the National Weather Service, and did on a county by county basis a counting of the tornado per square mile, and for a lot of locations for all the counties in Georgia and most of the counties in the U.S. that had in states that had a decent number of tornadoes, where you could get some kind of statistical inference from that. And certainly Westmoreland County was one of the highest. There's another concentration down in around York and
Right.
Southeast Pennsylvania. Why is it just a matter of speculation? But my thought would be that I think probably there in that Westmoreland County area that you're getting up close to the Laurel Highlands, where you begin to get into a little bit higher terrain. And my thought is that there's probably a little bit of a low-level jet that forms there as the air gets squeezed a little bit. The Pennsylvania tornadoes, unlike say Georgia, where often the surface to 5,000-foot flow may have a little bit of a southeast component. Most of the time when Pennsylvania, especially the low-level flow, has a southwest component. And so my thought was that that low-level wind starts to, and the mountains there run almost north-south. So that southwest wind starts to get squeezed a little bit up against the mountains and accelerates in a little bit of an enhanced low-level jet. And of course, the shear then is a little bit enhanced. So my hypothesis would be that it relates to that low-level jet. And of course, as the speed increases, the warm advection, the moist advection in there goes along with that. So you get a little bit of an extra destabilization to go along with that increase in the shear. And the combination of those two is energy helicity index kind of thing, the Cape and helicity arguments. So that would be my hypothesis.
Yeah, and I know even like during the winter time, it seems as though the warm air, when it floods in the
interesting thing about, I was going to say, the interesting thing about Georgia is that you might think that the tornado alley would be down near the Gulf, but instead the tornado alley in Georgia is just a little bit north of Atlanta, where you start to get into the mountains. In some of it, actually, the alley is actually in the mountains. It's not in the highest population areas. And they're over around in just one county east of Huntsville, Alabama, the same kind of thing. And so there may be a little bit of an orographic lift, as well as maybe some increased shear as the flow is going up and over the mountains. Again, it's all just a hypothesis, but there does seem to be some orographic influences in these. Even if you go into Oklahoma, there's a little mini tornado alley there near Moore, and there's a little bit of a east-west, not a very big slope, but there's a little bit of an east-west slope there that maybe is focusing things. And out in Denver, out around where the new international airport is, east of Denver, it's been well known for decades that there's a mini tornado alley out there, phenomena called the Denver Lee cyclone, where they come down off of a little bit of an east-west promontory, a little bit of high spot, and you get a little bit of a wake low that sits down in there and enhances the thunderstorm development, enhances the vorticity source.
Thank you, Dr. Forbes.
Next, Mark Borden.
Yes, Dr. Forbes, nice meeting you. Thank you for the presentation. When you showed Agnes, the flooding from Agnes, that's sparked my memory that back in last summer, I was in Lancaster County and I went into one of the road cover bridges, and they had the sign about the water depth there. It was just quite amazing. I was just wondering if you'd like to comment more about that, because that was just, I couldn't believe how high that was.
Yeah, the water levels there were just incredible in some of the places. Up in around the Williamsport area, up into around the Wilkes-Barre area, just tremendous flooding. And if you get down into Johnstown, Pennsylvania, they have markings on the side of some of the buildings, the level of the 1936, the 77, the 1889 floods, and the water depths there, more than a story high, are those kind of things are scary. And then of course it's not just standing water, it's water flowing so fast that none of the Olympic swimmers would even have any kind of a chance of surviving it.
Wow. Yeah, it was just, I was like, the bridge was so much higher and the water was way down. So I was like, that must have been a lot of rain.
Yeah, some places had 18 inches.
Right. Thank you very much.
Sure, thank you.
Another question in the chat from Dorian. What was it like to cover the May 31st, 1995 tornadoes in State College?
Yeah, that one, I was on the faculty at Penn State then and was supposed to be preparing. There was an American Meteorological Society conference that started that Monday. The tornadoes hit on a Friday, as I'm recalling. So I was supposed to be preparing my presentation, but we knew there was going to be a tornado outbreak. And so I was work a little bit on my presentation, and go look at the weather maps, and a lot of people are doing that. The thing that strikes me about that day was that there was an upper air feature that was pretty far away, but it was very concentrated. It was a cold pocket that was coming in from the northwest. The Storm Prediction Center had seemed to be concentrating instead on a weak dry line like cold front that was pushing east, and rather than that cold pocket. And so their discussion in the afternoon, they downgraded the tornado and severe risk a little bit with the argument that dry line like cold front feature had slowed down. And that to me was whoa, you need to go just the opposite direction in terms of your thinking, because that upper cold pocket, that means that it's going to catch up to that warm moist air as it comes into eastern Ohio and western Pennsylvania. So that to me was, whoops, it's time to stop working on my presentation, start watching the radar, start watching the weather map. And so I went in and we started looking at the radar. It only took about an hour after that before all hell started breaking loose. It began actually up in Ontario, but then worked its way down into the US. I think it was after the main part of the school year was over. So that was just students that were there for the summer, and graduate students. But as I recall, as the outbreak began, the word began to spread that the hey, Forbes is in there looking at hook echoes on the radar. It was in like a little closet that was part of what's now the modernized fancy weather station that you have. Then it was sort of not much bigger than a closet. And I was in there with a tripod taking photographs of the radar screen. And you saw one of those snapshots. Word got out about that, and slowly but surely that little room started filling up. And just as the tornado had passed and the next tornado over was hitting the Williamsport area, the radar crashed. Maybe it was overheated from all the people in the room, I don't know. But but we caught the full cycle of that Moshannon tornado, and so but that was quite an experience to be seeing that hook echo, as good as any hook echo that I'd ever seen anywhere in the United States at that point. I mean, it was like pictures of the radar that you saw published in the journals because they were so classic. To see that going through the mountains of central Pennsylvania was not something that I had expected to see. And then the next day I went out and was doing some ground surveying, and then after that chartered a Cessna aircraft and was doing aerial surveys of all of that. So, but the trees up in the forest there, knocked down by that Moshannon tornado, fortunately it was pretty much unpopulated, so it didn't injure or kill anyone, but it certainly mowed down the trees. You had to, if you got up on top of the uppermost tree that fell like, pickup sticks on top of each other, you were 10 feet above the ground up on that top layer of trees. So that was pretty spectacular. That's all something that I'll never forget.
All right, we got
Thank
time
you.
for maybe a couple more questions. First is from Jacob Hare.
Hello, Dr. Forbes. Thank you so much for being here. I have a question. So I know it's already difficult to predict tornadoes a few days out, but are there any factors like preseason that might say this is going to be a little bit more active than normal, like whether it's like an El Nino or La Nino might determine something, or just like some preseason factors that might say this is not going to be a good season in terms of tornadoes?
Yeah, there's been studies that have tried to look at that, including some of the informal studies that I did. A lot of them have looked at El Nino versus La Nina, and none of those worked all that well for the year as an entirety. But sort of in a nutshell, winters or cool seasons that had La Nina tend to be very active in terms of tornadoes, especially down in the Gulf Coast states. Years with El Nino tended to be a little bit more active out in the central U.S. chaser part of Tornado Alley in the spring summer time period, but the predictability, not 100%, not kind of in the same range, maybe in skill as the ability to predict the hurricanes, whether the season's going to be above or below normal, maybe not even quite that high.
Thank you very much.
And then now Skylar.
Oh, thank you, Dr. Forbes, for taking so many questions. What would you say outside of academia was your greatest learning moment during your career? So maybe like a forecast bust where you realized that you were looking at something wrong.
Oh, wow. There's a good question. My biggest learning experience outside of academia. Well, let me answer slightly a different question, and maybe I'll come up with the direct answer to the question you did ask. But the biggest eye-opening experience in going from academia out into the forecasting world or the operational world when I went to the Weather Channel was just, and especially having to cover the entire country as opposed to one forecast area, was that the experience was, holy cow, what have I gotten myself into? Because when I first got to the Weather Channel, the warnings were individually on pieces of paper that were spitting themselves out of the printer. And it was kind of like the old episode of I Love Lucy, with Lucy in the candy factory, with the candy coming down the conveyor belt. The conveyor belt in these outbreaks of tornadoes was going pretty fast, faster than I could keep up with. So I'm trying to sort the papers, and I couldn't read all of the warnings. I could just try to grab out then which were the tornado warnings and cover those, until finally then one of our computer guys made a switch that I could actually manually turn off the severe warnings in these outbreak days and only get the hard copies of the tornado warnings. And then over time, the folks at WSI that were doing our computer presentations came up with a way of increasingly better ways of actually displaying the warnings right on screen with the radar, so that you could interrogate the radar and the warning showed up right on there, that you didn't have to go to these sheets of paper anymore. So, but so kind of answering your question, when I first got to the Weather Channel, it gave me a much greater appreciation for the hard work that the folks at the Weather Service had to do, and in, say, TV stations or whatever, trying to cover all the storms and try to cover all the warnings that in these outbreaks had to be dealt with. The problem was that if you're localized, you only had to deal with them every so often. Me, it seemed like if I got one day off per week, I was lucky, because the storm that was in Oklahoma one day was going to be in North Carolina the next day, and I'd still be covering it while the other guys were getting a little bit of downtime. So that was the biggest change from academia. I don't know, I guess to answer the rest of your question, you have to learn from others as you go along. You have to keep up with the journals, with conferences, and so I would be going to AMS severe storms conferences and getting the journals and trying to learn from others. So and this, I guess, would be the direct answer to your question then. So while I was at Penn State, until maybe the latter years, you were sort of looking at stability indices and some crude measure of wind shear as ways of trying to anticipate how bad of a tornado day it was going to be. I think around the time that I was about ready to leave Penn State, and certainly they improved as I was at the Weather Channel, some of the folks at Norman, either the National Severe Storms Lab or Storm Prediction Center, or a combination of the two, were coming up with these indices, and like energy helicity indices, the supercell parameter, the storm prediction, the tornado parameter, significant tornado parameter, etc. Those kind of things that were combining into an index form, shear and instability and so on. So those were big advances, I think, in terms of predicting tornadoes and predicting in advance how bad days were going to be in terms of the threat for tornado outbreaks.
You had to learn those during your career because they weren't around yet?
Yeah, you had to keep up with the research community in terms of knowing what was possible, what was the state of the science, or the state of the art, as we sometimes call it, in order to be up to speed. Otherwise, you're going to fall behind the competition.
Well, to be fair, I haven't thought about the weather technology of 2040 very much, so thank you.
Well, Dr. Forbes, thank you so much. You've almost gone through an hour worth of questions, so thank you so much for doing so. As we wrap up, any final words, any parting thoughts, anything to kind of put an exclamation point on this great evening?
Well, it was certainly my pleasure to be here, and I'm certainly always like to answer questions. And I guess as a professor, I was always notorious for using every minute of class time and sometimes beyond that. So this evening has probably been no different from that.
Yeah, that's awesome. Thank you so much on behalf of the Central PA AMS NWA chapter, all of us that came. Thank you so much for taking your time, sharing your expertise and knowledge. This is by far the biggest group of people we've had attend any of our events. And I think that's certainly related to having you. If we just bring you to all of our meetings, our chapter is going to thrive, I think, right? So thank you so much. Let's give him one last round of applause here, either virtual or otherwise. Fantastic. As we close here, again, for the folks that maybe weren't on right at the beginning, would encourage you guys, if you want to be added to our email list, to either drop an email in the chat sent either to me or to Bruno or to Danny, I guess, Chrissy, who's our secretary. We'll get you added to the email list. We're also on Facebook and Twitter. Another logistical note, this recording will be uploaded on our YouTube channel if all goes smoothly. If not, we'll certainly share that out via email. But look for that on social media in the coming days, and feel free to share that with friends, neighbors, etc., those that weren't able to attend. But in closing, Dr. Forbes, thank you so much for coming tonight. We really enjoyed hearing from you. I wish you all the best in your continued retirement. Hopefully plenty of opportunities to get out and hike, and at least you're not having to deal with snow overnight like we may be waking up to tomorrow morning.
Yeah, good luck. Thank you.
Thanks so much. Have a wonderful evening, everybody, and we'll be in touch. Take care.
Thank you.
Thank you.
Thank you. Thank you.